Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Picture this: it's late. Your GPU fans are screaming, and an AI agent just submitted another experiment. You wait. Minutes turn into hours. Finally, the result appears and it fails, not because the idea was bad, but because it was never worth running in the first place. This is how most machine learning agents live today. They guess first, they execute blindly, and they pay for every mistake in compute and time. Humans don't work like this. We pause, we think, we rule out bad ideas before touching the keyboard. So here's the unsettling question: what if our AI agents could do the same? And that's where today's story begins. The story is inspired by a research paper with a bold question: can we predict before executing machine learning agents? Written by Jingxing Jing and Ningyu Zheng, supported by a team of researchers. At its heart, this paper asks something deceptively simple: what if an AI could think first and run later? Today's ML agents live in a loop, generate a solution, execute it on data. Look at the feedback. Repeat. It works, but it's slow, painfully slow. Some benchmarks take 9 hours just to evaluate one idea. That's not intelligent scaling, that's compute bleeding. Humans don't work like this. We don't try every idea, we discard bad ones in our heads. So, why can't agents? The authors borrow an idea from something called world models. Instead of touching reality every time, you build an internal sense of how the world behaves. In this paper, that world is data. The proposal is radical. Before executing two ML solutions, ask a model to predict which one will perform better. No training, no GPUs, just reasoning. If that sounds risky, good. That's what makes it interesting. To test this, the authors define a new task: data centric solution preference. Here's how it works: you give the model a task description, a summarized data analysis report, and two competing solution codes. Then you ask, which one is better and how confident are you? No execution allowed, just judgment. They didn't stop at theory. They built a real data set, over 18,000 solution pairs across computer vision, NLP, and data science. These aren't toy scripts, they're full ML pipelines. And the shock: reasoning models pick the better solution over 60% of the time. That's far better than random guessing. And better than bigger code must be better heuristics. The models weren't counting layers, they were reasoning about data. Then comes the practical payoff. The team built an agent called for agent. Instead of generate, execute, regret, it does generate many ideas, predict the best, execute only a few. They call it predict then verify. The results: 6 times faster convergence, 3 times more exploration, and better final performance. Execution becomes a confirmation step, not a fishing expedition. This doesn't mean execution is dead. Reality still matters. But the lesson is powerful. Reasoning is cheap, execution is expensive. If AI agents can learn to think before they act, we don't just save compute. We unlock a new way of doing machine learning. And that leaves us with one final question: if an agent can predict outcomes, how long before it predicts discoveries themselves? That is the future this paper quietly points toward. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.